I'm Anil Kumar. Welcome to my series on quadratic functions. We have taken 6 very similar applications in this particular video. The concept is to work with rate. And all these equations which will be formed will be kind of quadratic equations, and we'll solve them by factoring. Purposely, the numbers taken here are simple enough, and so you can factor and find the solution. So you can at present pause the video, copy these 6 questions, solve them, and then look into my suggestions. Let us take their solutions one by one. Question number 1 here is, Anil bought some pens for $80. If he had bought 4 more pens for the same amount, which is $80, each pen would have costed $1 less. Find the number of pens he bought, right? So we need to find the number of pens he bought. So let that be x. So let the number of pens equal to x. Now we are saying Anil bought some pens for $80. So rate is what? So rate is total quantity by this total amount divided by this, right? So let x be the total pens and this is the total cost. So rate is dollars per each. So rate of pens is 80 over x, right? So that is dollars per unit, right? This is dollars per pen. Now, if he had bought 4 more pens for the same amount, that means still the amount is 8. 4 more means x plus 4. Each pen would have costed $1 less. Of course, it would be lesser, right? So rate for x plus 4 is how much? He is still spending $80 but able to buy x plus 4. So many dollars per pen. Now the question says, if he had bought 4 more pens for the same amount, right, each pen would have costed 1 less. Now, so this is 1 less than previous price, right? It's cheaper, you got more, right? So the equation now becomes 80 over x, take away 80 over x plus 4 is equal to $1. So that is the difference. Is that clear? So that is how we form our equation, and this is going to be the base for most of the questions which we are going to solve in this video, right? Now the idea is how to solve this. So we need to take common denominator. So when you take common denominator, this gets multiplied by 80, right? We get x plus 4, and that also gets multiplied by x, right? The common denominator here is x times x plus 4, right? All this is equal to 1. Now you will cross multiply, right? So when you cross multiply, you get 80 times x plus 4 minus 80x equals to x times x plus 4. So these are the steps involved. We need to now solve for x. One way is, of course, you can expand and simplify. The other way is we can factor out 80, right? And then we can just expand and simplify. So 80 times x is 80x. Let me write like this. Okay. So what we get here is 80x plus 8 times 4, 320, minus 80x equals to, expand this, we have x squared plus 4x. Now 80x and minus 80x will cancel. We can take 320 to the other side. So we get 0 equals to x squared plus 4x minus 320. So now we have a quadratic equation where we can factor. We are looking for a product of 320 and sum of 4. So what could be those two numbers, right, to factor? So the numbers could be, so that is what you need to work, right? So the numbers which are difference of 4 is, we can see like this. We have 320 here, so which could be factored. This is negative number. We could write this as 16 times 20, right? Do you see that? 16 times 20 is 320. And if I keep the number 16 negative and that is positive, when I add them, I get 4x. Perfect. So that means I could use sum and product, and I can write this as x plus 20 times x minus 16, right, equals to 0. And that gives us answer that x is equal to minus 20, or x is equal to 16. Right? So it cannot be minus 20, right? That is not possible. So this is called redundant solution. However, that is possible. X equals to 16. So find the number of pens he bought, which is x. So our answer here is 16. Okay. So now we can write down the answer. He bought. So Anil bought 16 pens. Is that clear? So that becomes our solution. So I hope these steps are clear, right? So I hope these steps are absolutely clear. Now in the second question, we'll reduce some steps, make it simpler to solve. It is a very similar question. So let's have a look at question number 2 now, which is Anil bought some pens for $20. If each had cost 20 cents less, he could have bought 5 more for the same amount. Find the number of pens he bought. So let x pens, right, he bought. Okay. For $20, correct? Now see here, we are given if each had cost 20 cents. So there is a conversion of unit from dollars to cents. So it's a good idea to write this in 20, 100 cents. So when we have the same units, then there are no problems, right? So that is kind of important to see. Now, let x pens be bought for $20. That means rate of each is going to be, we'll write it in cents, will be 2000 over x cents per pen, right? Each. Clear? So that is the first scenario. Now we are saying that if each had cost 20 cents less, so the difference is 20 cents, he could have bought 5 more for the same amount. So he's still paying $20. Now we are buying $20, but we have x plus 5 pence, correct? That is what the situation is. So in this case, what is the rate? This is the reduced rate, right? So reduced rate here is, we'll convert this back to cents, which is 2000, but we purchased 5 more, so many cents per pen. Clear? And this difference is given to us as 20 cents, right? So from that, we get our equation, which is 2000 over x minus 2000 over x plus 5 is equal to 20 cents. Okay? So that is what we get from if each had cost 20 cents less. So this equation, does it make sense to you? So is a similar equation which we got in the first question. Now the idea is how to solve and simplify, right? So now we'll look into a simpler solution for the same, right? So these steps are, we could actually divide by 20 also, right? We can take 2000 common. So think like this. We are taking 2000 common here, right? So we have here 1 over x minus 1 over x plus 5 equals to 20. Is that clear to you? Now you can divide by 20. So you have 100. When you divide by 20, 1 over x plus 1 over x plus 5 equals to 1. So we divided by 20, right? So what we have done at this stage is, here we have taken common factor, correct? And then here we are dividing by 20, both sides. So we get 1 here, dividing by 20, we get 100, right? Times all this. See, it looks much simpler. And now we'll just cross multiply. So this time we have 100 within bracket. We'll just cross multiply. So we have x plus 5 plus x. Sorry, it was minus. Very sorry. Minus. This is minus, right? So minus x over x times x plus 5 is equal to 1. Now we'll cross multiply. So we have 100 times x plus 5 minus x equals to x times x plus 5. Right? Now this is x minus x is 0, so 5 times 100. So we'll add one step here, equals to x squared plus 5x. Right? Bringing this 500 to the right side, we get x squared plus 5x minus 500. Now we can factor, we are looking for sum and product, something which will give us 500. That's a big number. So what you could do here is, we need minus 500, correct? So you could split this, saying it could be like, let's say 100 times 5, for example, right? So we know the bigger number is positive, right? So 100 could be 25 times 4. And now if you combine these numbers, we get 25 and 20, right? Keeping this as negative will give you 5. So we can factor this. So we get this as x, we need this as positive, so x plus 25 times x minus 20, clear? So that means x is equal to minus 25 or x is equal to 20. Now this minus 25 is not valid because x has to be greater than 0. But this is okay, right? So now we get, let x pence be bought. So x, number of pence, is 20. So therefore, number of pence bought equals to 20. Is that clear to you? So that is how we are going to solve it. Okay? So in this particular solution, you saw, we kind of simplified it by taking this as a common factor, dividing. So we are working with smaller numbers, correct? Now in the third case, we'll simplify our solution even more, cut down on the steps. So as we move along, we'll see how to modify and work better with our numbers. Question number 3 here is, the two numbers differ by x. The difference of their reciprocal is 0.1. Find the numbers. So we have two numbers which differ by x. So that means let the numbers be, they differ by x. That means what? If one is x, the other one is x minus 5. You could also take it x plus 5. They differ by x, correct? So these two numbers differ by x. And says difference of their reciprocal. Now, if I do the reciprocal, then this is a bigger number, right? So when we say this statement, which is the difference of their reciprocal is this. So reciprocal is 1 over x and 1 over x minus 5. However, x minus 5 will be a bigger number, right? So we'll write that first. So 1 over x minus 5 minus 1 over x should be equal to, so difference of their reciprocal is 0.1. Now 0.1 can be written as 1 over 10. Do you see that? So when I say 0.1, it is equal to 1 over 10. Let's write it in fractions. It is easier. Correct? So that is our equation. Now we need to solve this equation. So we'll do the same thing. We're just taking the common denominator, x times x minus 5, multiply. We get x minus 5 equals to 1 over 10. Now we'll cross multiply, right? Now when you open this bracket, x minus this, what you get really, let me show this, x minus x plus 5 in the numerator, right? And multiplied by 10, we'll just cross multiply, equals to, this goes there, x times x minus 5. Is that clear to you? So we did cross multiplication. Now once we have done this cross multiplication, we do see here x minus x is 0. So when you multiply, you really get 50 here equals to x times x minus 5. Correct? We'll open this and solve on the right side. So we get 50 equals to x square minus 5x. Bringing this 50 on the right side, we get 0 equals to x square minus 5x minus 50. So now we have to split 50 so that the difference between the two numbers is 5. So 10 and 5 can work for you. So we can write this as x minus 10, bigger number because minus 5, times x plus 5, correct? So that gives us the value of x equals to 10 or x equals to minus 5. The two numbers differ by 5. The difference of their reciprocal is this much. So those are the two numbers. Now we are not saying whether these numbers are positive or negative. So both are relevant answers, correct? So both are possible solutions for this particular situation, correct? So find the numbers. So one combination could be when x is 10, right? Now if I write x equals to 10, the other number is, we have 10 and the other one is 10 minus 5. 10 minus 5. So we get the numbers as 10 and 5. On this side, if I take x as minus 5, the other number will be minus 5 minus 5. So get minus 5 and minus 10. So these are the two solutions. So in this case, we get two solutions, right? So we have our answer, which is the numbers can be (5 and 10) or minus 5 minus 10. Does it make sense to you? So we are not saying natural numbers. We are not restricting the set of numbers. So therefore, we have to write both the answers. Right? So I hope you have understood this solution. Now the next question is very similar. So I'll actually change the next question a bit. And this question now is the two numbers differ by 3. The sum of their reciprocals is 0.7. Find the numbers. Let me make a change here. So we'll say, when we say two numbers, we are saying natural numbers. So in this case, we are restricting ourselves to x belongs to natural numbers. Clear? Okay. Earlier, we got two answers, right? Integer values. Now we'll restrict to natural numbers and solve this question. It says, two numbers differ by 3. The sum of their reciprocal is 0.7. So we are saying two numbers differ by 3. This time we'll take one number as x, the other as x plus 3. So they differ by 3, right? Clear? Now when I do reciprocal, which reciprocal will be bigger? That will be bigger, right? So we are saying 1 over x minus 1 over x plus 3 should be equal to 0.7. That is the difference, right? Correct? So this is sum of their reciprocals is this. Sorry, sum. So that sum is this. So sum of their reciprocal is 0.7. Now 0.7 can be written as 7 over 10. Clear? It's good to write fractions than decimals. Again, we'll do the common denominator. So we have here x times x plus 3, and we could write this as x plus 3 plus x. See, this time we took x plus 3, not x minus 3, right? So there is a slight change in the way we defined our variables, and we get 7 over 10. But doesn't really matter. You still get the same correct answer. Correct? So what we get here is 2x plus 3 in the numerator will cross multiply. So let me write 10 times. This becomes 2x plus 3 equals to 7 times. When you multiply this, we get x squared plus 3x. Is that clear to you? So we multiply and then cross multiply. Now let's open the bracket. So we get 20x plus 30 equals to 7x squared plus 21x. Bringing the terms together, we write 0 equals to 7x squared plus 21x minus 20x minus 30. Correct? Now we have a quadratic equation to solve, which is 0 equals to 7x squared. 20x minus 20x is plus x, and we have minus 30. We're looking for two numbers whose product is minus 30, but sum is, 30 times 7, right? So we're looking for two numbers whose product is, let's do it on the side, minus 30 times 7, right? And sum is 1, correct? So very close, these numbers should be very close to one another, right? So what could be these numbers? 30, 10 times 3, for example, right, will give us 30, right? But 3 times 7 is 21. That doesn't. 15 and 2 is a good combination, right? So we can have 15 and 2. So as soon as you do 15 and 2, we have a number which is 14. The other one is 15, and the difference is 1. So we could associate negative sign with the smaller number since we have plus x. So we'll split this as 7x squared plus 15x minus 14x minus 30. Correct? So we have 0 equals to, only x is common here. So we get 7x plus 15. On this side, we can take minus 2 common. So we get 7x plus 15. Now, 7x plus 15 is common, so we have x minus 2. Now, that gives us two solutions. And the only valid solution is x equals to 2. Correct? So, the valid solution is this. That gives you x equals to a negative number 15 over 7. Since we are restricted to natural numbers, we are saying not natural number, right? So not in domain. So we'll not take this, but we are going to take the other one. Perfect. And therefore, the two numbers will be what? Find the numbers. So we have, the numbers are 2, the other one is 2 plus 3, and 5, right? So the other number is 2 plus 3, which is 5, correct? So that is how we are going to get our solution. Is that clear? So in the first part, we had been working with the numbers, and you saw how we could work very easily where we have something kind of a reciprocal, and it converts into a quadratic equation which can be solved by factoring. Now let's move on and take some examples which are distance, time and speed examples. So in between, let's take a small break and then we'll discuss how to solve questions which are similar kind but where we are comparing distance, speed and time.